right, for those of you listening at home, hi Polly.
Hi, Polly.
We are checking off the first half of homework 8B-1. Let's hear what you have.
Polly? No, she just isn't feeling well. Yeah. Although, I feel like Courtney doesn't have a phone right now.
She's not on the phone, so we actually don't really know where she's.
All right, we'll catch up Sophie when she gets back. All right, let me read off the answers as best I can. I'll be describing the max, min, etc. Number 1, red writing utensil if they're ready. Conversations later. Number 1, the max is at 6. The min is at -2. The baseline is at 2. Check those first. The amplitude is 4. You didn't really need to write that, but gentlemen, you really can stop talking for a little while. You've got to be listening on this. The horizontal shift is pi over 3. Again, the numbers they gave on their pre-formatted graph is not the most useful. You'd have to do like common denominator pi over 6 in order to have it make sense. So what I did is I just sketched it. I did pi over 3 to the right, and then started counting by pi over 2s. So, should I just sketch this? Mm-hmm. All right. Do I have a copy? It is number 1. Yeah. Let me just do this on the board. Number 1, it should look something like this. Again, the baseline is at 2. The max is at 6. The min is at -2. The horizontal shift is pi over 3 to the right. And you're going to be counting by quarter periods. In this particular case, the quarter period the period is 2 pi, so the quarter period is pi over 2. So we're going to be, did I say to do it? Oh, I didn't say to do 2 periods. Maybe you didn't have to. I'm going to do 2 periods just because I like doing it. Eventually on the test, I will ask you to do 2 periods with 5, 6, 7, 8. Now I'm going to be adding pi over 2 each time. How do you do this? Like if I did this on a test, what will you do? How do you do pi over 3 plus pi over 2? Yeah. Good. All right. Common denominator, such as 6. I will rewrite this first starting thingy as 2 pi over 6, and then the pi over 2 is 3 pi over 6. Just go ahead and leave it like that. So this will be 5 pi over 6, 8 pi over 6, 11 pi over 6, you get it, 14 pi over 6, 17 pi over 6, and so on. 20 pi over 6. Some of these are going to reduce. 23 pi over 6 and 26 pi over 6. Again, reducing will give you full credit. Not reducing will lose a point or 2. So you need not be fanatic. 8 pi over 8 is pi. And then you can just reduce them later. And if you forget, it's not going to cost you a heck of a lot. 10 pi over 3 and this is 13 pi over 3. Okay? Now, this is a positive cosine graph. Can somebody tell me what positive cosine graphs look like? No, go ahead.
On the I don't know what they're called, but you put 8 pi over 8 for one of them and all the others.
8 pi over 6. Wow, this guy's I was totally spazzing out. Thank you. 4 pi over 3. Oof, yeah, that would have gone down the cliff and flame. So, thank you. What does a positive cosine graph look like? Where does it start? Where does it go? Yeah. Starts at the max and goes, has to go down.
Yeah.
So if I'm pi over 3 over, and here's the center of the graph, is my first dot going to be above the center, on the center, or below the center? Like here's the center of the graph. Go.
Above.
Above. It's going to be at the maximum. So you go max, base, min, base, max, base, min, base, max, and then smooth curvy graph, not sharp pointy teeth. And there you go. Does that make sense? Number one. Okay, number two. I wonder if I should just grab it on the board. Yeah, why not? Life is short. Here's the equation. Y equals 1/2 cosine of parentheses. If technically there's a 1 in front, parentheses, and then you can do pi or x, doesn't matter. Okay, minus 3 pi over 4. Paren plus 2. Let me just analyze this for you. The very first one is the baseline. So y equals 2. The amplitude is the absolute value of a half, which is a half. The horizontal shift is 3 pi over 4 to the right. The period is 2 pi over 1, which is just 2 pi. So the quarter period is 1/4 of that, or 5 or 2. Okay, so there's your raw material. So you're going to start the base of y equals 2. And now, if the amplitude is a half, you're going to have a very, very narrow looking, short looking graph. So this is at 2, this is at 2.5, 1.5. So to make it so small. Horizontal shift is 3 pi over 4 to the right. And again, if they give you a suggested graph, feel free to just ignore it and write your own. That's actually what I do. It takes less time than trying to fit it onto theirs. 3 pi over 4. Now you're going to count by pi over 2's, which is really 2 pi over 4. So I'm going to count by that. So I'm just going to do 5 dashes this time. So 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4. Question, gentlemen?
I was just saying, it's kind of funny how every time like we get a graph, we're doing math, they're always like, if they give you this or if they give you that. But
But it's
you
always
always
you.
give us this.
Oh yeah, well,
I think
in a
it's
certain sense, the computer generates the graph. So they being the people who designed the program. It's not a euphemism for me. This
Well,
way.
yeah.
I mean, if it's a test, then yes, that's.
It's not the
It
test
sounds
they
so,
give
like,
you. Yeah.
I don't know, universal in a way. Like when we're in our future lives doing our pre-calculus math problems, and if they give us the multiples of pi over 2 on our graph.
Well, you just said they, by the way. So it's similar.
Yeah, I know, that's why I said that.
Oh, I see.
It's just funny.
They is like the pseudo-evil math overlords of the universe that, yeah,
Yeah.
make
You-
weird
like,
graphs.
I don't think you've ever said it, and then if I give you, it's always, and then if they decide to red like throw a crazy one at you.
Like, yeah, well, okay, like 70% of the time, they is usually me. But 30% of the time, it might actually be
It
some
just
sort of
makes you
random.
sound not as at fault.
All right.
That's not-
I completely disclaim any responsibility, even if it's my fault.
Exactly.
This is a positive cosine graph. So we're going to start at the max and go down. So, have a quick look up here for a second. Horizontal shift of 3 pi over 4, so there's our center. Are you going to put a dot above, on, or below it? B. Where's my first dot? Above the center, on the center, or below the center? I think.
Is it above?
Above, correct, because you start at the maximum. Then you go base, min, base, max, base. So it's going to be a very shallow curve. There you go. So what did I give you this so far? Okay.
How are you so good at drawing the curve?
Yeah, I can't.
I just do it a million times. It'll
No,
get
like, mine's still look like mountain.
better. It's okay. Number 3, I'm going to try doing this verbally. See what happens. The baseline is -1. The max is -0.5. The min is -1.5. So it's going to be a very short looking graph as well. The horizontal shift is pi over 3 to the right. You're going to be counting by pi over 2, otherwise known as 3 pi over 6. So So start at 2 pi over 6, and then the numbers should be 5 pi over 6, 8 pi over 6, 11 pi over 6, which is actually identical to this. They just happen to like using pi over 3 as a horizontal shift. Right? So pi over 3, does that make sense? So you should mark up your x-axis like this. It'll be below here, the like baseline of -1, and then half above, half below. Your very first dot should be at pi over 3, comma, the maximum, which would be -0.5. Then it should go to the baseline, then the min, then the base, then the max, then the base, then the min, and so on. Does that make sense? All right, number 4. The baseline is 1, the max is 4, the min is -2. Should be in between a height of 4 and a height of -2. There's a horizontal shift of, careful, pi over 4 to the left. That's another reason the graphs go goofy. They didn't give you any space to the left. So you should go pi over 4 spaces to the left and mark it. There's pi over 2 is the counting on the x-axis, this quarter period. So I would count by 2 pi over 4s. The very first mark should be at the maximum at -pi over 4. So go pi over 4 to the left, which is -pi over 4, and then go up to 4. Gentlemen, you're paying attention. Because there's a certain facial expression you use when you're chit-chatting about unrelated subjects. And that was it. So, just saying. It's about as obvious as a duck with a white dust. So, don't.
Even in math?
I dare say. Alright, so there should be marks at -pi over 4, positive pi over 4, positive 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. The very first dot should be at -pi over 4, comma 4. Then you should have one at pi over 4, comma 1. Then at 3 pi over 4, comma -2, and then so on. Make sense? All right. Questions? I mean, I did number 1 and number 2. Any parts of the analysis of 3 and 4 you need? Have you feeling a little better on that? Kind of so? All right, I'm about to give you, take out your notes, please. I'm about to give you the ability to graph the next 2 problems, number 5 and 6. There's a little bit of weirdness going on here, and this time the worksheet generator actually did this deliberately. They're not just trying to mess with your head. If you'll notice, there's no inner parentheses. We need to fix it. Now, a little story. This is a made-up story, so I can't say it's true. It might be true in another universe, who knows. You're familiar with input and output, right? What does input behave like? Like, what does it do? It does the opposite of what you expect. Correct. Can anybody name the order of operations? Like back or parentheses, exponents, multiply, divide, add, subtract. What do you do first? Multiply or divide? Whatever comes first from left to right. Because multiply and divide are pretty much the same creature, just forward and backward. That was a sort of trick question, sorry. What do you do first? Exponents or addition? Exponents, definitely. What do you do first? Addition or subtraction? Whatever comes first from left to right. Good. Now, that's the order in our universe. We are outside of the function. It's sort of like if you look in a mirror, you're outside of the mirror. If you could think like magically you could be cast inside the mirror, or you're inside that little, trapped inside the mirror, oh no. Just think it makes good fiction. Everything in the mirror world would be backward. And if you stand in front of a mirror and wave at yourself, I realize everybody does this, but if you're waving with your right hand, what's your mirror image waving with? With left hand. Everything's reversed. In the same sort of way, in input, once you go in here, the order of operations is different. It's backwards. in the input zone, in the input universe, so to speak, what would you do first? In the order of operations? Addition or subtraction. And maybe from right to left, who knows? And then you do multiplication and division. Then you do exponents, and then finally, when everything else is done, you do parentheses. Totally bizarre. I have a hard time even picturing what that would look like, but it's true. Second part of this weird story. Has anybody in this room ever heard something even remotely like, young man, young lady, you're not going anywhere until you clean up your room? I've heard this several times when I was growing up. I was notorious for having a messy room, but that's aside. And I did go up and clean it up, and then ta-da. Think of the input universe. You get sucked into this alternate negative universe, and you're just about to go out, and you hear, young man, young lady, you're not going anywhere until you mess up your room.
Mess up.
You're not going anywhere until you stop finishing your dinner. Excuse me. If I've told you once, class, I've told you 100 times, don't take out your notebook. Everything's completely topsy-turvy reverse. That's what's going on in here. So, what does this have to do with the problem? You tell me. Can somebody simplify this? If I get like 3 parentheses x plus 2, how do you simplify that? Like, there's only one thing to do that you could do. Distribute. What do you get?
3x plus 6.
3x plus x. Everybody okay with that? That's simplified. What if I asked you to unsimplify 3x plus 6? What do we call that? Factoring by what?
GCF.
GCF. 3 parentheses what? I'm kind of staring at you. X plus 2. That's unsimplifying. Look up here. There's a rule in algebra that says you're supposed to simplify before you solve. Like, you're supposed to make it look neater before you actually try solving it. It actually saves a lot of aggravation, too. Unless you're in the input universe. Young man, young lady, you're not going anywhere until you mess up your room. Students of the advanced mathematics, you're not going anywhere until you unsimplify that inside stuff. Do it. Now, the very first objection you might have is, but Mr. Geiklin, there's no GCF. There's a GCF of 1. You're right. And usually you say, there's only a GCF of 1. And then I usually say, don't bother. But let's just say you're walking down, like say a mathematical alley or something, and you get sort of mathematically mugged, and somebody comes up to you and says, hey, I want you to undistribute 6. I said, that's not a GCF of 6. I can't pull that out. What are you, crazy? Said, you want your face on the other side of the alley? You don't. Pull out the 6. Okay, I'll pull out the 6. Now, is it possible? Yes, it's going to make a mess. I know this happens to everybody all the time. But y equals -3 sine of what? Tell me how to pull out the 6. I mean, here's a 6, but parentheses what? What would you have left? I mean, this part is not too bad. What would be the first term? Anyway, x minus what? Go. Pi over 6. Again, it got messier, but that's because somebody mugged us. And we're pulling out something that we normally wouldn't pull out. You can do it. Just by the way, this is a little bit off topic, but I want to show you there is no cosmic reason why you have to pull out the GCF. It's easier. It's far easier. It makes life easier. totally desperate. Let's just say you have 2x plus 12. What would any average sane person pull out? 2. Yeah. I'm going to pull out a 7. Is it possible? Yeah, it's going to make a mess, but I don't know. We're in advanced math class, we can make messes. What would be in here? Come here, tell me what it is.
2x over 7.
Yeah, just leave it as a fraction. 2x over 7 plus
12 over 7.
12 over 7. Ta-da. I mean, who would do that? I don't know. But you could. You could pull out pi. You could pull out 0.6. You could pull out 3 radical 11. It's horrible, but you could do it. You can pull out anything. I mean, don't accept 0. I mean, don't do that. That would be bad. You'd be like, hey, just pull out a 0, and then people start dying in your problem. That's bad. So, my main point is this. I'm not so concerned with what happens here. Everybody look at her? I'm not so concerned with whether this is messy or not. I just want this by itself, and I want a number in front. How come? Because this is A, B, H, K. Those are the pieces we need in order to make our graph parts. Now, one thing to point out. Let me hold this up, just as a demo. Pretend you can't see that dot part. Well, you can't, unless you have it in your nose. What's the horizontal shape? What does it look like? Guess what a lot of people assume it is if they just look at that equation. What's the horizontal shape?
Pi.
Pi. They think it's pi which direction?
Right.
Pi to the right. What is it really?
Pi over 6.
Pi over 6 to the right. See the difference? If you don't unsimplify it, if you don't get it in proper form, you'll get the wrong horizontal shift. And you won't have B as your divisor. Let's see if we can put this together. Can somebody tell me, Sophie, what is the very first thing we find in any graph like this? Sort of on the board. Yeah, the what? Like physically, the what? Kind of, sort of. The baseline, it is a move. Can you give me the equation of the baseline in this particular case? But let's say, ignore this now. Use this. What equals to? Y equals to, excellent. Is in the equation. Yeah. Question.
What happened if it was like, pi over, 4, something?
Oh, if this is pi over 4?
Up top.
Oh, up top?
Yeah.
Oh, pi over 4, interesting. And you wanted to pull out a 6? You take pi over 4 divided by 6, which is, I agree, it's awful.
Pi over 20.
Pi over 4 divided by 6. What I would do is multiply by the reciprocal. Pi over 4 times 1/6, which is pi over 24. It'll get pretty ugly looking, and there's no way around.
Pull out the first number until x is 1.
Exactly. That's the main goal. Get x by itself. Even if there were pi x, you'd have to pull out a pi, which would be yeah. We got the baseline. Michael, what would you get after the baseline? Amplitude. In this case, what is it? Sort of. That's A. Amplitude is the distance from the baseline to one of the extreme heights of. It always has to be what kind of number? Yeah. In other words, how do you find it?
Absolute value.
Take the absolute value of A. So the absolute value of -3 is what again? 3. So the amplitude is 3. It's always a positive number. What do you find after the amplitude, Jack Love?
The horizontal shift.
Yeah, which in this case is what?
Down pi over 6.
Pi over 6, which direction?
To the right.
To the right. Can somebody find the period for me? John. What is the period normally for sine and cosine?
2 pi. Oh,
2 pi.
2 pi.
Now, when do you do, how do you calculate it?
2 pi over b.
2 pi over b, which in this case is 2 pi over what?
6.
Correct. Does that reduce?
One over 3.
Pi over 3 is your period. That's a very small graph period. Normally it's 2 pi. Pi over 3 is really tiny. Can somebody give me the quarter period? No.
5 over 12.
Right. 1/4 of pi over 3 is multiply those and you get pi over 12. You're going to have to count by pi over 12s in order to graph this thing. Speaking of which, let's graph it. So, Julie Sishan, what do you graph first? Baseline, correct. Go up to 2, and then while you're at it, can you give me the max and min? The max is 5, correct? Correct. The max is 5. The min is -1, because it's 3 spaces up from the base, and 3 spaces down from the base. Nice. What do we do next? Do or not?
Well, now we can say, horizontal shift.
Yes. Where is that?
So we start at 5 over 6 to the right, and it's sine, so we start on the baseline.
Correct. Excellent. Now, what kind of a sign? Is it positive sign or negative sign?
It's positive sign, right? But didn't we change it? Oh, for just the amplitude. we changed it.
Correct. For the just to find out how big the amplitude was, we have to evaluate it.
Okay.
The original equation is
And then it's negative.
a negative sign graph. What does that look like? Starts where, goes where?
Sorry, at the base, it goes down.
Correct. Starts at the base and goes down. A negative sign graph is always going to look like that. Here's the center of the graph. Yeah, and by the way, while you're at it, am I going to put a dot above the center, on the center, or below the center? Right on the center. Am I going to go up or down from there?
Down.
Down. What do I count by?
Pi over 6. Oh, sorry, no, pi over 12.
Pi over 12. Tell me how I could do that. I'm starting at pi over 6. How do I add pi's over 12? Yeah. So, why is it up 2? That's the baseline. It's over pi over 6. This dash is pi over 6 spaces over. It's not 1. This -1 is the height. Why did you move it? That's the horizontal shift. The horizontal shift is where the graph starts from running. You count by the quarter period. So here's, in other words, you move over this much, that's the start. And then to get the next spaces, you count by quarter periods. Okay. Like over here, we started, the horizontal shift was 3 pi over 4 to the right, but we were counting by 2 pi over 4. They're usually different. The horizontal shift and the quarter period are usually quite different. In rare cases, they might be identical, but that's an accident. How do you do 5 over 6 plus 5 over 12? No.
You get a common denominator.
Common denominator, like what?
12.
12. What is this really?
So it's 2 pi over 12.
2 pi over 12. Give me the next 5 branches.
So it's 2 pi over 12, 3 pi over 12,
Uh-huh.
4 pi over 12,
Yep.
5 pi over 12, 6 pi over 12,
Right.
7, so on, so on.
Yeah, 6 pi over 12, 7 pi over 12. Good enough. Do you want to, I'll do 8 pi over 12, why not? Do you want to do those reduced?
Yeah, so 2 pi over 12 can go back to 1 over 6.
Pi over 6, okay.
And then 3 over 12 can be pi over 4.
Pi over 4, good.
And then 4 pi over 12 can be pi over 3.
Let me stop for just a second. You're absolutely right. This is what scares me. Whenever a bunch of people see this, they say, I was right all along. I can do pi over 4, pi over 3, pi over 2, pi over 1, pi over 0, pi over -1, pi over no. First of all, the pi over 0 would kill you. The pi over -1, good grief, what are you doing? You're going over to the other side of the graph. So, yeah, please do not. That's a total accident. Yeah. This really totally scares me if they don't, there is a 5 pi over 12, and you're, look, I was right. No, you're not. 7 pi over 12, nope. 8 pi over 12 is, that 2 pi over 3? I think. Let me double check on that. 8 over 12 is 2 over 3.
Yeah.
Okay, hidden. And the other one's legal number. So where's my next dot? No, finished off on. What height? Or, max, base, and min?
It's negative, so it's min,
Correct. Min, then
base,
base,
max,
max,
base,
base,
min,
min,
base.
base, etc. Smooth curvy graph. Done. Does that make sense? All right. If you could take a look at your worksheet 8B-1, maybe number 5, if you're not already there. Number 5 and number 6 need to be unsimplified before you try graphing it. So my suggestion to you, first, unsimplify it. Second, oh, and by the way, I don't see plus anything at the end. What does that mean? It's plus 0, correct. So the baseline is at 0. Unsimplify, then find the 5 parts. Base, amplitude, horizontal shift, period, quarter period. For graphing purposes, the only purpose of the period is to find the quarter period, because that's what you can find. Go ahead.
Redraw the graphs?
I'm sorry?
Can we redraw the graphs?
Absolutely. I redraw the graphs all the time. You feel free to use that space on the bottom to draw your own graph. Yeah. I actually find these graphs more annoying than helpful.
Yeah.
Number 7, I'll have to figure out, I managed to tell the computer not to put an annoying graph there. I need to figure out how to do that for the rest of them. But number 7, it's already unsimplified. Go ahead and do it. Everybody fan these? Feeling semi-comfy? Alrighty, the rest of the hour is yours. Go ahead and chisel away at those. I would like the entirety of 8B-1 tomorrow. And Polly, hopefully you have that already. God bless your efforts. Email me if you have any questions. Have fun. God bless your healing. See you
You
soon.
have to take out, do 7?
You do have to do 7. Yeah, but 7 you don't have to do undistributing.